Now we want to develop the equation for Rayleigh line, where the involved formula is conservation of mass and also conservation of momentum. So we use the formula. This is the formula for, let me see. So conservation of mass and also conservation of momentum. So this is the formula for momentum. So we go back to the picture. Sorry. Okay, it's right here. So this is the conservation of momentum, and this is conservation of mass. So actually when we put it together, the two formula, so this is equal to formula equal to 1, and when we consider the PV equation, PV square, we replace the rho and also we replace the V, where rho is equal to pressure over RT, and the velocity is in terms of Mach number times speed of sound, and we replace the speed of sound, square root KRT, and finally we simplify. We can get this equation after we cancel out the R and T. Yes. And then when we go back to equation 1, where P1 minus P2 is equal to this formula, this equation, we put the PV into this formula, which is PKMA square. So with considering the location which is 1 and 2, so P2 KMA2 square minus P1 KMA1 square. So we rearrange according to the initial condition and the final condition. The initial is 1 and the final is 2. So after we rearrange, and we can compare the two condition, the pressure at the end and the pressure at the beginning. So this is the formula that we can get for Rayleigh line. And then we want to compare between the two lines, the Fano line and the Rayleigh lines. What is the intersection? So we just make it Fano line and Rayleigh, Fano equation and Rayleigh equation equal to each other, where Fano line also have P2 over P1, and after some rearrangement, there are a long story right here, so we can finally get the comparison between the Mach number at the final condition with the Mach number at the initial condition. So this is the formula, this is the intersection between the two lines. So if we go back to the slide, remember that not the shortwave, okay, this line, this is the two intersection that I mentioned just now. Okay, so we obtain this formula and also the intersection. Remember the converging and also the diverging nozzle to create the supersonic speed. When we make the nozzle bigger and bigger, the nozzle diverge and the cross-sectional area become big. It will not sustain or maintain the speed of the supersonic speed. Therefore, after some time, it will it will shock will happen, and it will decrease the speed, and other parameter also will change. For example, if you look at here, the pressure will increase because the speed is decreasing, so the pressure will increase, but the stagnation pressure will decrease. So you have learned about that, so you can do revision why it decrease. And also, of course, the speed decrease. If the speed decrease, the Mach number also decrease. The temperature increase because of the speed decrease. The stagnation temperature remain constant. Density increase, and finally entropy increase. So remember, this is not isentropic process. Okay, now we want to see what happened to the entropy along the shock wave. So this formula